Sometimes, things don't go to plan. Believe it or not, not everything I do is about restoring an old piece of vintage hardware or making a YouTube video, as was the case with this eBay listing, a very cool but very average 9-inch CRT from 1982. But sometimes, things just happen, and they're too cool not to talk about, and a project just naturally evolves. The eBay listing of this CRT had a single generic photo and didn't mention a key detail. This CRT had been modded. I think they intentionally chose to leave this out, as many collectors might have passed on it, but for me, that made it even more interesting. Not only had it been modded, but it looks like the mod had been done in the 80s. You see a ton of modern ones these days, but seeing one that might be over 40 years old is just really exciting, and makes me think about what the scene was like back then and who might have taken on a project like this. Now, I've got a full restoration plan for this CRT, but I've done some tests and know the sound doesn't work. So I want to try to repair the original mod, but for those of you who watch the channel, you know I just can't stop there. There may be one or two other plans I have for this little guy along the way. And before we get going, I want to thank Bamboo Lab and our channel sponsor, PCBWay, for their support in this video. More on them later, but for now, this one goes deep. So let's begin. This thing seems in fairly good shape. It's missing a door, it's got some dirt, a few scuffs, a little bit of yellowing, nothing that I can't take care of. On the back we see where the audio port was added. I wouldn't have done it over the sticker, but maybe that was the best place. Speaking of, we've got a couple falling off, so we'll hang on to these. I've learned to test bits for old screws. I don't want to run the risk of stripping it, so I want to make sure I get the one that fits in really snug. Pulling away the panel, we see where the audio wire was added, and we get the first look of our mod. Immediately you can tell how old this is. No chips in sight, all discrete components, and what look like germanium transistors and diodes. I can't wait to get this thing out and take a look at it, but also, we see a small sheet of paper in back that's getting me pretty stoked. I love the way these CRTs were designed. If you pull away the bottom panel, you get complete access to the bottom of the circuit board. It makes troubleshooting really easy. We can also see where the mod is pulling its power. I'm not sure the voltage yet, but we can test that later. But for now, we're going to have to remove this in order to remove the mod and the case itself. And with that disconnected, we can continue to remove the top of this case to make it a little easier to work around. This audio jack is soldered in, so I'm going to have to clip it anyway and replace it with a brand new one. As I finish removing this, I'm really appreciating the time it took to fit all this together. You can see that the speaker holes were drilled one at a time. All of these components you could probably buy at a Radio Shack or an electronic parts supplier. The circuit board looks like a kit that was hand assembled, and as I start to pull it away, I get a good look at the card underneath. The card is a spec for a 2N1305 germanium transistor, and it actually has a spare taped to it. The type of care and forethought making a mod and adding components so that the next person could replace them is just really cool to see. This handle looks pretty severely yellowed, which I'm going to try to fix, but that's the only thing that was. And at first glance, the inside looks really clean. I'm not seeing any indications of bulging capacitors or charred transformers, no cracked PCBs or signs of water damage. You know, all the things that you want to look for before sending high voltage through a monitor that's 40 years old. And the fuse is still good, so we got that going for us. Let's power it up and see what we're working with. You'll see some people have these giant signal generators or test pattern generators on their bench, but I love this guy. It's an ESP32 powered one that only requires USB power and can put something on screen. As the picture starts to come in, I get a little worried when I'm adjusting the vertical hold and it's not really doing much. It's at that point I remember I live in North America. So I changed my test pattern generator to NTSC and definitely better. The next concern is the contrast. As I just touch the knob, it comes in clear, but as I continue to adjust the picture, it washes out again really quick. There's definitely an issue with the contrast knob. If I play with it, I can get it to hold, but it's not reliable, so we're going to have to dig in on that one. As far as everything else goes, the screen is looking pretty clear. We do have some geometry issues, some rotation issues, but all of those things can be fixed. For now, we can put this aside and work on the case. The plan is to strip the case, create a new volume decal as it's looking a little worse for wears, and then give it a fresh coat of paint. I tend to do a lot of sanding. It's not that I like sanding in particular, but it kind of comes with the hobby. You really need to be careful when you're working on something this old. Even though the US banned lead-based paint for residential applications in the late 70s, it was still in use long into the 80s for commercial and manufacturing. I'm taking some time here to chamfer and deburr these holes so the paint job comes out nice and crisp. To replace the volume indicator, I 3D printed these little circles. I'll apply the logos using water slide decals after I sand, prime, and give them a fresh coat of paint, the same color that I plan on using on the case itself. After the paint is fully cured, I can slide on these decals, making sure to get all the air bubbles out. And after that's dried, I can trim out the sides and then use a little bit of sandpaper to clean up the edges. And with the case freshly painted and the new decal applied, we can move on. In order to troubleshoot the mod, we need to know what voltage it's working with. And when I check the pin that the original cable is soldered to, it looks like we get about 14.3 volts. I'm also going to solder on an RCA connector to make testing a little bit easier. Now, I wasn't getting any volume before, so the first thing that I'm going to work on is this switch. Now, this acts as both the volume and power, and so this is what we call a switched rotary potentiometer. I really want to reuse this original switch, and so I'm taking my time to use a fiberglass pen to clean up all the corrosion around the leads. After that, I'll solder on some new wires and use a little heat shrink tubing to make sure that I'm not exposing anything. Inside is a wiper that drags across a tight coiled wire. I'm using a little deoxit to remove any oxidation or buildup on that wire to make sure that we've got good connectivity. After that, it's time to test, and unfortunately, I'm still getting nothing. The switch actually looks pretty good, so now it's time to test the components. As I test the components one by one, it's not good news. Almost every single one is bad, including the transformers. And due to the age and rarity, I can't find drop-in replacements, so I'm going to have to set this one aside and call an audible. Just so we can get things up and running, I'm taking the old switch and wiring it into a newer audio amp. Now it's time to wire up a new power lead. I'll add in a little UV solder mask to protect the joins, and I'm going to put a connector on the end so I don't have to solder it directly to the board. We'll finish up the underside with a little cable management and a QR code that's a reference to the work that we've done. This sticker was clearly an asset tag that was aftermarket, so a little IPA will clean that up, as well as a magic eraser makes quick work of some corrosion on the front. I've added a nice JST connector for the power, which is helpful in tight spaces when you can't always see what you're plugging in. Now that we're finished with the underside, let's see what we can do about the CRT. And this is where I remind you that you should only be working inside a CRT if you know what you're doing and know how to take appropriate precautions. Before we get to the knobs up front, I use a ceramic screwdriver to adjust the vertical size and then just start tapping on components. It may seem strange, but it's a really good way to detect cracked solder joints, issues with the PCB, or some damaged or faulty components too. Now, I did lose picture with that tapping, but I'm pretty sure it was the brightness, which is part of these front controls that I plan on cleaning anyway. I'll do a cosmetic clean first to get rid of the dust, and then it's back to the deoxit to make sure that we're removing any kind of oxidation that's inside of these potentiometers. And speaking of cleaning, I take every opportunity to get the dust and grime off the monitor. Now, I really should have discharged this CRT before, but now that we're going to be working on the rotation piece of it, it's absolutely critical. For this monitor, you can make all the other adjustments just by turning some dials, but not the rotation. That requires physically turning these copper coils on the yoke, and it's not really for the faint of heart. So before I attempt that, I'm going to take the opportunity to do a little bit of cleaning. I know this is a nitpick, but I am not a fan of these wire twisty ties for cable management inside electronics, which is why you'll see me replace these with these blue ETFE cable ties. They've got a really large operating temperature range, they're chemical, UV, and even flame resistant. They're as close to archival as you can get. And a quick tip, when replacing cable ties, you can wrap the new tie before you take off the old one. It makes bundling a lot easier. Now, before I go messing with this yoke, I want to mark where it currently is for a reference point. Now this is the tricky part. You're going to need to remove any epoxy that's tying the copper coils to the glass itself. I do this by using a little solvent and then getting in there with my scalpel, but making sure that I'm not actually scoring the glass. Then you're going to need to loosen 2 screws, one in the back of the yoke and one in the front by the neck. You can see that there's still some epoxy up front that's preventing it from moving. And notice that I'm cutting directly towards the plastic and not down at the glass. This is the most fragile part of the CRT. With that freed up, I can slowly rotate the yoke. I'm wearing an insulated glove, I'm only touching the plastic, and I've got one hand in my pocket to prevent any voltage from crossing my chest. Once I've got it in a good spot, I slowly tighten one of the screws to keep it stable. And that's looking pretty good. It's time to lock it in. With the monitor powered off, I can tighten both screws. Again, not too tight, you don't want to crack the glass or damage the yoke. And you can see just how subtle of a change that I made. And to fix it into place, I'm going to use some 2-part epoxy and wait till it gets to this consistency. You want it loose enough to where it kind of gets into the coil, but you don't want it to drip. Make sure to put it in a different spot than the old epoxy, otherwise you might not get a good hold. And just to be sure, I use these blocks to tip the monitor at an angle while the epoxy dried. Now that's out of the way, we wait for the epoxy to cure, and we can move forward with putting it all together. There are a few more finishing touches I want to put on the case, like removing some residue and reapplying some stickers, but that can wait until later. What I want to focus on right now, though, is soldering in this new audio connector. I've decided that keeping the original label is more important than ordering a new backplate and reprinting a label in order to make it look cleaner. I really want to make sure I preserve this as much as I can. When I solder in a new wire on back, I want to make it a plug. That way I don't have to worry about soldering or desoldering when I want to completely remove the backplate again. And I'm also a stickler for labeling, which is really going to help in what we end up doing next. In order to mount the new amp, I end up 3D printing this mount in ASA and also include a little bit of cable management as well. And as I want to mount this rotary knob, I'm cleaning up the hardware a little bit too, so I'm giving a little polish to the nuts and washers that end up turning out pretty good. I did buy a new rotary knob, but I kind of like the original better and it's in pretty good shape. I am going to use the new set screw though. The little clip I printed on the mount comes in handy for cable management, as inside the monitor is pretty tight. I did try retro-brighting the handle, but unfortunately it didn't do anything, so I ended up giving it a coat of paint in the same color that I used on the case, and it turned out really good. I've added a brand new speaker that I use a little bit of hot glue to fix to the case. The original rotary knob stood a little too proud of the surface for me, so I created this spacer to make it nice and flush. And for preservation, we have to include the original board and transistor card in case the new owner wants to take on that project. That QR code links to a GitHub page where I've reverse engineered the schematic. So with a brand new painted case, a new working audio mod, and the CRT cleaned inside and out and calibrated, I'm getting really stoked to try this whole thing out. I was a bit disappointed that I wasn't able to find the components I needed in order to fix the original mod, but I've taken the schematic and I've published it online, so maybe somebody can pick up where I left off. During the restoration this far, it really got me thinking, if I were to mod something like this, how would I go about it? One of the things that I love to do is use modern technology in order to keep with the theme of something, do a mod that could have possibly happened back in the day, and make it look like it just rolled off the factory line. So then it got me thinking, how would I add audio to this monitor? Well, a couple things come to mind. First, you do see some CRTs or some type of computer cases have a grill on the side of it. I want to do something a little bit more sleek and a little bit more high-end. Maybe something with a speaker mesh or a grill that I can actually build into the case. The other thing that I would do is take this volume, which on the side of it seems a little bit chunky, a little bit obtrusive, and maybe move it up towards the front, something that you would see it coming out of the factory, where you'd have a volume knob here. Now, something else we could do is actually add in an IR remote, so you could change the volume wirelessly. Now, a lot of TVs like this didn't have remotes back in the day, but in the early 80s, it wasn't unusual for a TV to have a remote, so that would still be keeping with the period. And if we had a remote, we'd have to have some kind of visual way to see what the current volume is. So that means some kind of on-screen display. Now there's a couple ways to do an on-screen display, but specifically for a monochrome monitor like this in the 80s, the way I'm thinking of doing it is literally just a video overlay circuit where you turn up the voltage or the brightness of the pixel in specific places, so it really looks like it's just overlaying on the current picture. In order to actually make the volume go up, we're going to need an amp, just like one of the originals, except maybe a little bit more sophisticated, something that a microcontroller can interface with rather than a knob. And then obviously we're going to need some brains for the operation, like a microcontroller, in order to control all of the stuff that we've got going on in this mod. So there's a bit more to do. There's PCB design and layout. We can start writing the software. We're going to have to create a new shell for a modified case where all of the components fit in and will house our new speaker. And we're going to have to figure out how to modify this current TV in order to pass through an IR signal. Again, the whole intent is that when this thing is done, it looks like it just rolled off the factory in 1982. All right, we got a bit to do. Let's dig in. In order to create a new case, I have to replicate the current one in sheet metal. Now, sheet metal bending is a little bit different than normal CAD design. You have to take into account the size and the radius of the curves, the thickness and type of metal. And in a lot of cases, you have to include relief cuts so that the metal doesn't deform when it's bent. Now, all of this seems pretty complicated because there's a lot of rules to how you can go about this and what the machines that do sheet metal bending will actually allow you to do. The good news is that there's software that handles it all for you. I'm using a sheet metal fabrication plugin for FreeCAD, so there's no expensive software that you need to buy for it. And once I'm done, I can upload this file to PCBWay, choose my material, my finish, and they take care of the rest. Before I send it off, I use my Bamboo Lab A1 in order to test the dimensions of the case. I take a rear slice of it and then line it up with the actual case itself to make sure that all the dimensions and the screw holes match. This saves a ton of headache and ensures that the product I get back I know is going to fit. Now, because of the sheet metal process, I actually have to slightly alter the handle. In the original case, it had these insets or indents, something that I can't do with such a small batch, so I'm going to need to slightly modify the handle in order to fit a flat case with no indents. When I'm prototyping a new model, I generally print in PLA because it's easy and it's fast. For a final piece, usually I'll use something like an ABS or even an ASA, something that I'll need to print using my Bambu Lab Carbon X1 that has a heated enclosure, but for a prototype, this thing came out really, really well. For the speaker, I wanted to do something different. I wanted to have a mesh, I need to mount it to the case without screw holes, and so I decided to come up with this 3-part system. The A1 with its fine 0.2mm nozzle was pretty critical here, as I needed some really fine detail and tight tolerances. The model consists of 3 separate pieces, and these tiny little pegs that I'm using act to both fix the cloth and sandwich the pieces together in a press fit. The first thing I need to do is cut the cloth to size. I need to oversize it a little bit because I want to be stretching this across the base. I'm folding over each side and then securing it with one of those little pegs. I do this and work my way around the entire circle. When the cloth is in, the pegs sit a little proud, so the second piece actually press fits into those pegs and secures the whole sandwich together. I can then use these tweezers in order to pull the fabric taut and remove any excess from the outside. And this is the first part of the enclosure for the speaker. It looks really good, and so I can start to trim the insides of the cloth just to remove any of the excess. I then printed a replica of the cutout that's going to be the hole in the aluminum enclosure I get from PCBWay, so I can test this without having the enclosure there. Once the speaker is in, the final ring acts to secure the speaker itself and the whole enclosure to the case. This one took a bit of work, but it came out really well. I really wanted a remote. And not just any remote, I wanted it to be what I had in my mind of what a remote was when I was a kid. Now when I bought it, I was just thinking about the look and the buttons, but I didn't realize how much trouble it was going to give me. See, every remote has a unique signature, and there are libraries for them because they're known, especially remotes this old. But you guessed it, not this Zenith. Which means I had to use my Flipper Zero here in order to do the hard work of reading the raw signals, and then interpreting those raw signals, and then modifying the libraries that are out there for IR decoders in order to even recognize this remote. Now the Flipper Zero really is a Swiss Army knife for a lot of different types of wireless protocols, but at the end of the day it left me with a set of micropulses that it read for each one of the button presses. It was then on me to go and decode what those micropulses translated to and to adapt them into a current modern IR library. So, after a little bit of reading and a little bit of coding, I was able to write a library that actually understood what the remote was putting out, and that was just step 1. I really do enjoy bouncing back and forth from the software and the hardware and the hands-on stuff because it helps me reset my brain to work in lots of different types of media. Now clearly I couldn't leave the Zenith logo on, and none of the solvents I tried was able to take it off, so I had to go with the scalpel. The scalpel did a good job of taking it down to the bare metal, but I wanted the finish to be uniform, so I used a little sandpaper before polishing it back to a nice shine. For me, water slide decals aren't good for every job, but they work really well when you can cover an entire area. Notice that I printed a black line that helps blend in with the line below to make it look like it's a factory finish. So now that I've got over the barrier of writing software that can actually understand this thing, and I was able to get the logo on the way that I wanted, everything is really coming together, and I've got a essentially new old stock remote for my USI TV. One thing that I think I forgot to mention is that this thing doesn't have a door. The good news is that it turns out that this style of monitor case was actually pretty common. There turns out to be a few brands like Sanyo that use this exact case, well, kind of exact case, which we'll find out in a second, but I was able to actually have a lot of reference images in order to recreate this door. And just like with everything else, I don't print the full thing, I only print in sections when I'm doing test fits. And I'm glad I did, because this test fit didn't fit. These pegs are actually moved out further on the USI model that I have than the Sanyo reference one. And it's only when I get the thing to fit really nice where I start to work on the details. I got some really nice high-resolution images from Adrian's digital basement, and funny enough, his episode was the reason I even knew about this monitor's existence in the first place. Now I'm recreating these in vector, but I don't want to make it a sticker. I'm actually going to take this and build it into the 3D model itself in kind of an embossed look. I'm using the images to approximate the location and size of both the USI logo and the Pi 4, which is the model of the TV. And after a 10-hour print, I was really surprised about the detail level I was able to get on the A1. This level of detail is clearly more appropriate for a resin printer, but I am just really impressed how well this came out. A bit of primer, sanding, and black paint, and this thing will look stock. So we've given our custom mod the ability to interpret the signals from the remote, but how are we actually going to get it to see them? I came up with an idea that a lot of people told me wouldn't work, but I'm kind of stubborn, so I decided to try it anyway. I didn't want to cut any holes in the case itself in order to add an IR window, and so what I'm thinking of doing is actually putting a fiber optic cable behind the red LED power light. IR is infrared, it's not on the same part of the spectrum as visible light, so the light from the LED shouldn't interfere. If I can get a fiber optic cable close enough to the bulb of an LED, I might be able to pick up the infrared light passing through it. But in order to figure out if this will actually work, I've got a lot of testing to do. I've printed a holder to hold one end of the fiber optic cable right by the sensor. The other one I'm passing in through this aluminum foil just in order to make sure that the basic concept works without the LED in between. And it does, no surprises there. So now it's time to test it with a lit LED. I drill a hole in the circuit board right below where the LED sits. I cut the fiber optic cable at a slight angle so that when I position it, I'm trying to capture as most light possible through the back of the LED. Keep in mind, the fiber optic cable's not going to be exposed through the front of the case, it's only going to be the front of the LED. So I poke the front of the LED through the shield in my remote and start pressing buttons, and I'm getting signals. Definitely a promising result, but we'll see how it actually functions when the case is put back together. Let's take a quick second to recap the components of our mod. First, we've got the brains, powered by an ATmega 328. It's the same chip as an Arduino Uno R3. It's a bit older, but it does what we need. Its main job is to drive the video overlay circuitry so that we have an on-screen display. Then it can handle the button presses and ultimately drive the volume of our amp. The brains talk to the audio amp, which uses that 14 volts in order to power our speaker. We've then got power regulation, which takes the higher voltage from the monitor and brings it down to what the other components need. There's also some protection put in place so that if the mod gets a little squirrely, things will just shut down before it damages any chips. The video overlay circuit is powered by this LM1881 sync separator, which essentially takes the video input and gives all the information our brains need in order to overlay something on top of the video. We've given our main ATmega chip quite a lot to do, and so I actually separated out another microcontroller for the IR receiver. Its sole job is to decode the signals coming from the remote, so all the main chip has to do is think about whether a button has been pressed or not and not have to decode all of that at the same time. And now that we've got our schematic in a good place, it's time to do a little circuit board layout. by no means an expert, but I like to talk it through so that others can hear my thought process. And it starts with logical groups. I want to make sure that all the components that are completing one task are close to each other. Now there's also rules that you want to follow that align with this, like you want to make sure to have decoupling capacitors very close to your power inputs and your chips and things like that as well. So I really spread things out before I know what even my outline is going to look like. I create the right thickness for the traces for the voltage and the amperage that are going to be going through them. After that, you can start to apply your core principles like separation of analog and digital circuitry. Just take your time and keep referencing your schematic. And in a few weeks, we got our shipment in from PCBWay. The powder coat on the case came out really well, and if you can't tell, I'm going for a pure black Darth Vader look for this new upgraded CRT. The new ASA handles are a perfect fit, and we can move on to sanding and painting. Also in this shipment were our circuit boards. One thing I should have put a little more thought into is the size of these boards and where I'm going to mount them. I'm using a little blue tack on these standoffs in order to test different locations in the case to be mounted, and I think I found a good one right behind the handle. I'm going to prep some epoxy and put it in these standoffs. I'll leave the board in it so it doesn't shift around as the epoxy's curing. It's a little bit messy from the inside, but it definitely beats screw holes on the outside of the case. Now's the fun part. For the surface mount components, which are most of them, I'm using this stencil to apply some solder paste. Then comes the fun of sorting through all the components and figuring out which ones you're going to put on first. When I'm putting on components, I use the short to tall strategy rather than the small to large. It makes it a lot easier when you're using a combination of these flat chips and maybe some chunky capacitors. I use a large hot plate for these small surface mount components. You heat it up slowly so it doesn't warp the board, and at some point, all that solder paste just turns molten and everything fits right into place. I've got a pretty aggressive ground plane on this board as well, so some need a little extra help, even with the hot plate. After the components are on the board, I go through and I test every single connection. And after I've done that, I plug in the power and hope I see a light and not an explosion. I'm using what's called an ISP header in order to program the board directly rather than doing the chip aside from the board and then soldering it on. It also allows me to make updates really quick if I need to without taking anything off. And of course, aesthetics matter, so I need to make some cool custom white speaker cable to match. The final change that I need to make is on the CRT itself. I need to cut the cable that goes from the input onto the circuit board itself. Then I can solder on a plug onto either end so we can plug it into our mod, one for the input and one for the output. That way our controller can overlay the on-screen display for the volume. Once our epoxy is dried and the final board's put together, we can start finally assembling this thing. You'll notice that I added a notch in the hole for the speaker. Essentially, I've keyed it, so once it's snug in there, it's not going to rotate. Now we get to feed in our optical cable and give it a little cable management. I've also printed another holder for the board and added it on with a little super glue. When reattaching stickers, I want to use archival glue so they won't continue to yellow or damage the paper. They can also be easily removed at a later date if they need to be restored or replaced. All stickers matter, even the tiny ones. After some sanding and priming and matte black paint, the handle's looking really good. This has been quite the involved project, and everything coming together always feels really good. And at this point, you think I'd be dreading making a video about it, but honestly, it gives me a chance to look back at all the work that I've put into it and reliving some of those troubleshooting sessions and things like that. It's a lot of fun, and it's a big reason why I love doing this. I never know how a project is going to turn out. And honestly, I sometimes don't know what it's even going to be until I get into it. It's probably why a lot of my projects kind of get out of control, because I start with one idea and then I add about 10 others along the way. At some point, I have to decide where to stop, because there's always more that I can do. So for this project specifically, let's talk through what we've done and then about what we could have done or could still do later down the road. First off, the speaker and the amp turned out fantastic. The speaker looks exactly like I pictured it, and the amp has way more headroom than we need for this setup. The remote and the look and the feel of the OSD turned out perfect. The fact that it remembers the volume after you come off mute or even after you power cycle the TV. In the future, you could extend it to a full menu, be able to add multiple inputs and switch them, or even turn on and off the TV. All those things would require more modifications to the CRT, but it's all possible. And there's definitely room for improvement. On some video, you can see a subtle wave of the OSD, as well as a slight flicker to the CRT itself, and that doesn't happen when it's not plugged into the mod. Now this is some fine-tuning that's needed in the video circuitry and possibly board layout, but again, all fixable. And you know that whole passing IR through the LED trick? Turns out, it works pretty good. Now it's not 100%, and I'm chalking that up to the fact that this LED specifically is a little cloudy. I think if I were to get a more clear one, then that might boost the reliability. And that's going to be it for this video. Hopefully not for the project, as I'm going to be posting all of the files on GitHub so others can tweak and modify and make it their own. I also want to thank Bamboo Lab for sending over their A1 printer. It was a huge help in the rapid prototyping that I did and getting those really fine details on things like the case door. It turned out fantastic. I'm definitely going to be adding that one into the rotation. And of course, I want to thank PCBWay. The sheet metal fabrication that I used on this one came out absolutely perfect. The powder coat came out great. The bendings were precise and it fit really well. It was the first time I used that with them, so it was really good. And obviously the PCBs are always super high quality, and we can tell in kind of how the project came out. If you enjoyed the video, please like and subscribe and comment and discuss down in the comments. YouTube really does look at that engagement and use it in order to push it to a wider audience of people that might like what I do. And it helps me do things like this that are involved in kind of deep dive projects that hopefully you enjoy as much watching as I do building them. So thanks again, and we'll see you in the next one.